The goal of exploratory linear regression is to find a model that is strong and stable using as few predictors as possible. Why did I say the goal of exploratory linear regression? Because what we would really like is a theoretical model, and that theoretical model, when we check it with our observations, our data, holds up well. But even for a theoretical model, what we'd like to do is make it as parsimonious as we possibly can. That is, the simpler we can make the model, the stronger the model is, as long as it still is conforming or fitting with our data. That is, if our observations do not tell us that something is wrong with our model. R square increases when adding explanatory variables, even if the variable has no association with the response variable. So we talked about this before, that adjusted R squared can adjust just for chance increases, so it's useful in helping us find a parsimonious model. And that, in essence, wraps up what we're going to talk about in terms of new concepts with multiple regression, but I still have to finish my report. So let me go back and start working through this and seeing if it says what I want it to say and if it looks nice and clean. So I've gone ahead and we've already checked this first part. I'm reading it to myself. That's my silence. Okay, down here is where we probably need to start cleaning it a little more. We have this multiple regression model that predicts the number of physicians from the number of hospital beds and per capita income in the small city. We talk about the multiple correlation coefficient of 0.52 and the coefficient of determination of 0.27, which we got from this part that we're not actually showing. 27% of the variation number of physicians in small cities can be explained by the number of hospital beds. And then we provide the model. Now, we're not giving, at this point, we are not actually providing the definitions of these coefficients. We're not explaining that, and we could do that, or alternatively, we could wait until we have those in confidence intervals. Why don't we do that? So let's go ahead and put in our verification of validity of inferences. So what figure am I at? Figure 2? Okay, so this is going to be my fit plot. And let's look at it again. So we use that for two things. One, to check that the coefficients appear to be linear. So okay, and I need to hide this code. I want to show the output though, so I'm hiding the code but showing the output. And I can also say And then I need a probably a couple spaces like I did up here. I want to see how many I used. I used 3 up there, and then I created my figure, which I'm going to go ahead and copy that and create it here. And this will be figure 2. And this is a residual fit plot from a hospital beds and income model. Okay. All right, and then down here we did the QQ plot. And so I'm going to say something like this, and this is figure 3. And remember that we had these residuals here that were larger than I expected. All right, so I gave some caution here about our inferences. I need to hide this, only show the output. I need to give another figure. That's not it. Let's see, I need to give another figure heading. So this is figure 3 now. Okay, and let's make sure we have enough space here. Okay, so now that we have established that about our inferences, now we can go ahead actually and make those inferences. So let's look at the overall model again. What did we have here for our P statistic? A real small one for the overall model. The F statistic was 9.167. So I'm going to say and why don't I say this? Why don't I say R squared equals 0.27, and with that P less than 0.01. I usually like to put my exact P's unless they're really small, and this one was 0.0004059. Okay, and then we also can, let me go ahead and move this, and I don't need all of that. I just need those confidence intervals for the slope. Let me move that up here. Let me again hide the output. Or, yeah, I want to hide everything. So show nothing, just run the code on this one. Okay, and we can see it over here in our window what we need. So let's go ahead and interpret that. All right, so here are my confidence intervals. Let's go ahead and make them in an R Markdown format. So this is beta for beds. And then we have beta for income. And where I'm getting those numbers from is right here. 0.0047 because I have to move the decimal point 3 places to the left. And then this is all fine here, 6.43 and 23.55. And then my interpretation is that I am 95% confident that after accounting for income, an increase in the number of hospital beds in a city by 1 additional bed for every 100 residents is associated with an average increase of between 5 and 60 physicians per 100,000 residents. And I'm just as confident, let's see, I'm missing some words here. I did say average increase. And did I say that I was holding the, no, I did not. Oh, yes, I did, after accounting for income. I was going to say, did I say something about this being holding income constant? And that's what I'm saying there for accounting. I'm just as confident that after accounting for the number of hospital beds, an annual per capita income increase of $1,000 is associated with, I need that little slash so that that dollar sign shows up correctly, is associated with an average increase of between 6 and 24 physicians per 100,000 residents. Okay, so I can get rid of this down here. And now I think I'm ready for my conclusions. And so I wrote something in terms of the conclusions. And I have a few little R Markdown things to put in here because I didn't write this in R Markdown. Let's go ahead and put this in. And now I want to create a press release for the general public. Okay, let me knit this. I normally find that I have little errors here and there after I knit it, so I'm going to save it. I'm going to knit it. And let's take a look. We've already checked this pretty well here. Well, I thought I would find errors here and there, but it looks pretty good to me. I'll leave it to you to read what I actually wrote here, see if it makes sense to you. But that is my report. Thank you for joining me on the journey. This concludes my series on modeling response variables. Remember that we are going to do much more with modeling response variables, but that's the title that I gave for looking at a single quantitative response variable as a function of multiple explanatory quantitative variables. Don't forget also that even though I am concluding this series with this video, that I'm going to attach 2 more videos at the bottom, and those are going to be more in depth about mean squares and the F distribution. So I encourage you to watch those as well.